Hi, Algebra 2 students. All today is a quick review of what is going to be on the quiz for tomorrow. So I made a little list of topics right here. The idea that you need to know for a rational expression where it's undefined, which also leads to the domain. So as a little reminder, that's essentially looking at where the denominator is equal to 0 for the undefined, and then you have to restrict those values for the domain. When we talk about inverse, inverse means you're switching the x and y and then resolving for y. To simplify the expressions, the key here is to factor first, right? And then cancel out any common factors. For multiplying and dividing, same thing. You need to factor, treat it as one fraction. For dividing, remember that you're multiplying by the reciprocal. And then the last one, for adding and subtracting, the key there, make sure you get a common denominator first. And then you can add or subtract the numerators. So there's a super shorthand version of what is on the quiz, and then those basic ideas as to how to deal with it. So we're going to do just a couple of practice questions here, and then the rest of the practice will be the homework assignment in class. All right, so the first one, determine the domain. So I'm going to give you f of x equals x squared plus 7x plus 6, and then all over x cubed plus x squared minus 36x minus 36. So keep in mind, if the question said to simplify it, we'd factor everything. Because we're saying find the domain, then all we're focusing on here is the denominator. So take that denominator, set it equal to 0. This is a perfect example of doing some review of factoring by grouping, because you have 4 terms. So that's how we're going to do it. So take out the x squared, and we're left with an x plus 1. Here, if we factor out negative 36, we're left with x plus 1. And then we can take the x plus 1 in front, and we're left with x squared minus 36 in the back part. And then we can keep factoring that. So x plus 6, x minus 6. Set all of that equal to 0, and then x would come out as negative 1, x comes out as negative 6, x comes out as positive 6. So if the question said, where is it undefined? That's it. You'd be done. Because it says domain, we want to know what values we're allowed to have, not the ones we're not allowed to have. So we can say, like in set notation, this would be x such that x can't be, it can be anything but these, basically. So negative 6, negative 1, and 6. If this was an interval notation, I would strongly suggest put these on a number line. So then negative 6, negative 1, 6, because yeah, they have to go in order. And then I can see I have 1, 2, 3, 4 intervals. So in interval notation, this would go from negative infinity up to negative 6, and then union with negative 6 to negative 1, union with negative 1 to positive 6, and then last one, union with 6 to infinity. So please make sure to take note of what way you're asked to leave the domain. All right, number 2, we're going to take that question and just change it up a little bit. If I said, let's simplify, oops, making up my own spellings there, simplify f of x. All right, this is code for let's factor the heck out of everything. So let's do the part that we already know is done. So I'm using the exact same expression here. Just want to make that clear. So the denominator we know will come down to x plus 1, x plus 6, and x minus 6. The numerator, all right, well, let's go back and look at what that was. This is a little add multiply guy. So we can make this x plus 6 times x plus 1. All right, when we come on down, we've got lots of stuff in common. The x plus 6's will go, x plus 1's will go, and then all we are left with is 1 over x minus 6. Done. All right, one more practice question, and then we'll save the rest for class. And that is to find the inverse of f of x, but not the f of x from up above. I'm going to give you a new one. So we're going to use x plus 4 over x. Okay, for inverse, we are switching and solving. And so here, don't forget, f of x is a fancy old way of saying y. So now flip-flop. Anywhere that there's an x, it's now a y, and vice versa. So that means we have x equals y plus 4 over y. And now we need to be able to kind of move some things around here. So I'm going to multiply the y on over to this side. So that gives me x times y, and then equals y plus 4. Need to move both the y's to the same side. So I'm going to subtract this y over so that I get xy minus y equals 4. And then once the y's are on the same side, we can take the y out as a GCF. So when you factor it out, we're left with x minus 1. And then the last little step would be to divide to get that single y alone, because that's the goal here. So now I can say it's solved for y, and that is the inverse function, which that's just my little notation for inverse, would then be 4 and then over x minus 1. If you get to here and leave your answer there, perfectly correct. Nothing wrong with that guy. All right, we're going to stop there, and we'll save the rest of the practice for class.